Okay, so this 2x over here on letter C, maybe the 2x is 0, or maybe the 3x minus 1 is 0. And then I just solve each of them. X is 0 is one answer, and x is 1/3 is the other answer. And now I would like to go back to number 3, and I'd like to pull together some of the stuff we've worked on throughout the year at different and various times. If you look at number 3A, you get it all on one side, and I have x squared minus 5x plus 14. And my instinct is to try 7s and 2s, because that'll get me a 5. But I realize that there is no combination that will multiply out to positive 14 and add up to negative 5. So, what we do next is, I'm thinking there's no answer. And then I graphed it, just to confirm what I was thinking. Because isn't it true that wherever the graph touches the x-axis, those are the roots, or those are the zeros? Right? Are you with me on that? Hello? Right? Very important. Wherever it touches the axis, those are the roots and those are the zeros. So for instance, with this guy here, it would touch at 0 and 1/3. With this guy, letter B, it would touch at negative 5 and 1.5. Well, over here, I said, you know what? If there's no answers, no real answers, I'll bet you it doesn't cross the axis. So I graphed it, and this is what it looks like. So the graph never touches the axis, so then to conclude that there are no roots is an accurate conclusion. Okay? So I wanted to emphasize the fact that the graph you get matches the algebraic answer you get. Algebra is one way to arrive at the answer, graphing is a second way to arrive at the answer. Okay? All right, any questions? Yes?
Can you walk through C
Walk through C? Well,
after
Try.
you bring the...
no, I can't. I tried, I really did. Oh, do you mean you want me to go over C? Oh, okay, here we go. Do they share a common factor? When I was in high school, I had this great teacher, Mr. Brace, and the kids would raise their hand and they would always go, "Can you do number 4?" And he'd go, "Yes."
Oh my God.
That's funny. Mr. Brace was disturbing. He looked like Lurch from the Addams Family.
Oh, wow.
Did you ever see the movie The Addams Family or the show?
Yeah.
And he would go, "You rang." So he looked like that. He had a whole bunch of identical suits. He wore the same thing every day. Now we know that he changed his suits, and we know he got them washed, because back then, I don't know if you can remember this, back then we used chalk. And particularly there was a big fight between teachers who loved white chalk. Myself and Mr. Bruno were big white chalk fans. And then there was those who liked yellow chalk. Now, the reason people didn't like white chalk is because you had to press on it to get it to work on the board, and then it was harder to erase. But we who didn't like yellow chalk hated yellow chalk because it was so dusty. It would get all over your hands, and then you put your hand in your pocket, and by the end of the day, you had this big yellow mass right next to your pocket from the chalk. So Mr. Brace never had the masses next to his pocket. So we know that he had multiple suits, but they all looked exactly the same. He had a white shirt and a black tie and these black pinstripe suits, and he wore them every day. And he was such an intimidating guy that when I got out of college and I first got my job teaching, I used to go to his classroom and get advice. I did that for about a year and a half, and then I had kids and things get busy, and then I had heard that he actually retired. So I sent a letter to the school at Bayport, which is my old school, saying, "Listen, please just get him this letter. I just want to thank him." So I sent a letter to him, and he sent the letter back to me, but he had a post office. He would not give out his address. So he's just a very strange guy. And I had a friend of mine who was a police officer do a backtrack on the post office box to find out where he actually lived. And I found out his address, which ironically was 245 Thunder Road in Holbrook, and that's particularly ironic because Bruce Springsteen has a song called Thunder Road. And I sat outside his house and stalked him. I was parked in a car outside his house, and I was shrunk down like, because, well, I expected he would have like a creepy Addams Family house. So, and it was a little creepy. He did not own a television. Yeah, he felt that everything on TV was bad for your brain.
That's true.
It is true. So He wouldn't, he had nothing on, he had no television. And he had, this is not politically correct, but this is the facts. He had a retarded nephew. His nephew really was retarded. And I don't know his nephew's name, but Mr. Braze's first name was Doug. So eventually I got up the nerve to knock on his door and go in the house, and it looked like a normal house. But I would go in the house, and every day when I would go in there, the phone would ring at 4 o'clock, and he'd go, "Oh, that's my retarded nephew." And I would, he'd go, "Yeah." So then he'd pick up the phone, and he'd go, "Uncle Doug! Uncle Doug! It's 4 o'clock! 4 o'clock, Uncle Doug, it's 4 o'clock!" And he'd go, "What, Anthony? Thank you, Anthony. Yes, thank you so much. Okay, I'll talk to you tomorrow, Anthony. Okay, bye." And I'd go, "What was that about?" He goes, "Everybody needs a purpose. His purpose is to call me and tell me it's 4 o'clock." So, just a very, very, very strange situation. And he's also the best teacher I ever had in my life, by far. It wasn't even close. Yeah, he was really, really good. So he used to do things like if you asked if you could go over it, he would like pretend to
Wait,
try
how
to
many times
step
did you
over
go
it.
over his house?
Probably about 20.
Why?
Just because he was that great a teacher that I needed to learn from him.
Did you go specifically at 4 o'clock?
It's like if you lived fairly close to, say, Derek Jeter, would you go to his house to learn how to play shortstop?
No.
No.
Oh, if I knew him, I would. If I lived near Travis d'Arnaud, would you learn how to go play catcher?
I don't know that.
He's the next catcher.
Wait,
Okay,
do I know him?
you should. Okay, so anyway,
No, I mean like.
let's go over 6x squared minus 2x equals 0. Clearly, we should always look for a common factor first. And when I do that, it's 2x. So I pull out the 2x, and that leaves me with a 3x minus 1. Agree?
Correct.
All right, now you can solve a regular quadratic equation, right? Where I say maybe it's the guy on the left, maybe it's the guy on the right.
Yeah.
Well, I'm gonna do the same exact thing. Maybe it's the guy on the left. It's just that this time the guy on the left doesn't have a parenthesis. 2x equals 0. Maybe it's the guy on the right. That's the one in the parenthesis, 3x minus 1 equals 0. Then I just stop looking at them, or I start looking at them as just general linear equations. Just divide by 2, x is 0. Add 1, 3x is 1. Divide by 3, x is 1/3. So those are my answers, 0 and 1/3. Okay? All right. So what I say about questions like letter C is they're actually easier. But because they don't look like the other ones, we tend to not be as methodical or mechanical about it. And we're like, this doesn't feel right. But it really is easier. Okay. Let's take a look at today's situation. Are you guys all good for your quiz on Monday?
Yeah.
Tuesday? No?
Probably.
Well, listen, for what it's worth, I really think that those who chose perimeter for the last one, that's a classic fool me once, shame on you, fool me twice, shame on me. If you missed it this time, okay, you should never miss that again. You should have a little thing in your mind that says, is this perimeter or is this area? So, and I'll bet when you saw your mistake, you wanted to smack yourself in the back of the head. Would anybody like to smack themselves in the back of the head?
No.
You can do it for me.
Come on, give slap. Denozo.
Why
You know what I'm talking about, right? Would you like to explain to everybody what I'm talking about?
No.
All right, Gibbs is a great, is Gibbs one of the great characters in the history of television? He really is. He's a real man. In a day where they're trying to make men not men anymore, Gibbs is a real man. And he's got Denozo who works for him. And Denozo wants to be a real man, right? He's a wannabe real man, but he's not a real man. He's just not. But he tries to be, and he's trying to grow into it. And every time Denozo does something stupid, Gibbs will just walk up behind him and go, right in the back of the head. So it's a Gibbs shot, right there. It's, if you watch the show, you'll get it. It's really good. Who's your favorite character on the show?
Abby.
When we get another female dog, that's the name. Because you know we have Gibbs, Ziva, Denozo McGee, the cats, Abby, and if we get another male dog, it'll be Ducky. So Abby and Ducky are going to be in it. We're actually getting another dog this summer or fall, but it won't be a Central Asian. It's going to be a mini Aussie Shepherd, about this big, and her name will be Abby.
Will she be
Yeah,
fluffy?
that's as big as it gets. What?
Will she be fluffy?
They look like collies.
What the heck is that?
Lassie.
I don't get it. The one with the ears?
When we're done, I'll show you a picture of a
Really
mini
fluffy
Aussie
one.
Shepherd. All right, The ratio of the length to width in a rectangle is 2 to 3. Find the length in a rectangle. All right, so look, as soon as it says ratio, I'm thinking 2x and 3x. We always add the x to represent that thing they share in common. We did perimeter problems like this earlier in the year. Now, I have to multiply 2x times 3x is 6x squared. I should write on the side here 2x times 3x. I went a little fast there. 2x times 3x, length times width, is the area, which is 150. So does everybody see how the 2x and the 3x when multiplied gets you 6x squared?
Yeah.
Okay, good. What's my next? Now, listen, there's two ways we can go from here. Who thinks they want to go? Tell me what they think they should do next. Go ahead.
Divide 6 and then square.
You can divide by 6, that's fine. Okay, so I'm going to divide by 6, and I get x squared equals 25. Now, at this point, if you want to square root both sides, I get it. You can do that, and it works fine, okay? However, I want to get you in the habit of thinking like quadratic equations, so I would prefer to see you saying to yourself, oh, something is squared, let me get it all on one side. Just as a proper mindset thing. Now, this is a difference of two perfect squares. How do I factor this?
Square root it.
Yeah, double square roots, right? So this is going to be x plus 5, x minus 5. It's as if there's 0 x's in the middle, right? We did a bunch of these last few days. We didn't do any yesterday, but we did the last few days. All right, so maybe it's the guy on the left. Maybe it's the guy on the right. Subtract 5 from both sides. X is negative 5. Add 5 to both sides. X is 5. Now, one of these answers is ridiculous. Which answer is ridiculous? Why is negative ridiculous?
Because it just is.
Well, what does X represent?
Yeah.
Well, let's put things this way. If I plugged in a negative 5 here, I'd get 2 times negative 5 is negative 10. Is it possible to get a negative length? No, it's not. So the negative 5 is impossible. 5 is what we have here. And it says find the length. The length is 3x. So 3 times 5 is 15. And that's the length. The other one's 10, and 10 times 15 is 150.
I made a stupid mistake. That's what I did.
Go ahead.
I added the 3x and then 2x.
So that's a perimeter thing again. Gib slap. Gib slap. Let's go. Let's see the gib slap. Very good. Okay. Now, go ahead. Do it. Nice, fun question.
This one was how
Because it's 3x for the length.
If
And
you just did the square root at that point, because you said you could, it would be fine.
yes, I agree. And then you have to take the 5 and you have to plug it into the 3x.
Oh.
And that's how I get my 15. Okay? And then the length would be 2x, which would be 10. And 10 times 15 is 150. So I have my area of 150. Make sense? Okay. Do it. Quietly. This is a challenging question. Let's see if anybody can get it right. seconds or so. All right. So, how many people struggle? Yeah, I think the first time you see a question like this, there's a whole lot of struggling going on. But I think when you get done with it, you're like, really, that's it? It's that? Okay, all right, I can work with that.
Wait.
Did that sound like, have you guys ever seen the movie Gremlins?
No.
Yes.
That sounded like a mogwai.
A what?
A mogwai.
They had a little tiny.
They go like,
Right, like, oh, yeah.
I can do that. Sort of.
don't get the mogwai wet. Remember?
No.
Yeah, that's when all the little gremlins started popping out of it.
Don't forget after midnight.
Okay, so look,
There are these in desert people popping out of the sand.
we have a rectangle that measures 12 by 16.
What?
And then it is supposed to have a pedestrian pathway that's W meters wide installed all the way around it. So, there's my pathway that goes all the way around it. Yes?
I didn't know where to put the 16, where to put the 12.
Good question.
Doesn't matter. Because I flipped them.
One is longer. Usually longer.
Oh, okay, thanks.
Which side's longer?
The 16.
But it would make absolutely no difference if you switched them. You'd still get it right. Yes?
Can I say what you think you should do?
Fire.
Okay, I got the equation of 285 is equal to parentheses 12 plus W parentheses and then 16 plus W.
So close. It's 2W. Ready? This is W, right? Because it says the width, the walkway is W wide.
Obviously.
This is W. This is W. And this is W.
Oh.
So for the new rectangle, how wide is it? This is 12 plus what? What is this? What is that? W. What is that?
W.
So what's a W, a 12, and a W added up?
12W squared.
No, that's multiplying. Come on, add.
Oh. 14W.
2W,
Oh my god.
2W plus 12.
Oh.
You cannot add W's and 12s, so BB.
I could if I wanted to.
Oh, yes, you would be wrong every time. Now, what's this distance?
16.
2W plus 16.
I want to answer that one.
Now, Francine was in exactly the right direction. You then need to multiply these two. 2W plus 16 times 2W plus 12, because length times width is area, and in this problem, the area is 285. Okay? Now I'm going to pause at that point in time, because to me, that's the hard part of the question.
Yes,
Okay?
that's correct.
Does everybody understand why I put the W around the original rectangle?
No.
Yes, I do actually.
I don't.
James, why?
Because there's more. There's another.
What does it say in the problem?
They're adding more to it.
That's right. The pedestrian pathway is W meters wide, installed all the way around.
Okay,
So here's my all the way around, it's W meters wide.
I understand.
Now, why is it 2W plus 12 and not W plus 12?
Because you're only doing that in the two sides.
Okay, take a moment, look at your paper. What was your mistake? Everything.
I didn't do that whole thing.
I
Okay.
just did W.
I get the idea looking at Sammy and how he mentioned that we're doing like Tai Chi. I did not do that whole thing. Now, length. You ever see Tai Chi? I think it's the coolest thing. I really like to get into it at some point in my life. Tai Chi, it's an oriental, like, martial art kind of thing, but they would wake up every morning and they would go out in the air and they would go through these breathing exercises while they went through these stretching, moving exercises. And it looks like they're doing super slow-mo karate.
Yeah.
If you look up Tai Chi, T-A-I-C-H-I-A-I, it's a very, very healthy thing. It's kind of like yoga-ish in some ways.
I want to Pilates.
All right. Good? Have fun. Now, let's double distribute here. 2W times 2W, 4W squared. 2W times 12, 24W. 16 times 2W, 32W. 16 times 12, 192. Equals 285. I just wanted 116, 32, 192. Yep. Okay, so all I did was double distribute and then write equals 285.
58.
Now, I need to put everything together. 4W squared plus 56W. Now, I'm going to minus the 285.
Why?
Of course, I gotta get it all on one
right,
side.
83.
Right.
A 93.
93 it is. Minus 93 equals 0.
See, this is how I approached it a different one.
Okay, well, what's the problem now?
W.
What do you wish there was that there's not?
A 0.
I got a 0.
Oh.
Not a 0.
I wish there was a common factor of 4.
Oh yeah, that's true.
Don't you?
Yeah.
But there's not. What do you gotta do now that there's no common factor of 4? Plan B.
Plan
So-
B.
Times 4, and I get W squared
I don't have enough room for
plus 56W, just go below here.
372.
Let's see, 360, 372 is right, equals 0. Now, how many people walk around with the factors of 372 stuck in their head?
No one.
Nah.
Wish I could.
Factor, calculator time. Everybody go to Y equals.
Okay.
Type in negative 372 divided by X. Negative 372 divided by X. Now,
12 words.
go to the table, and start looking for two factors that are 56 apart.
what?
That makes sense.
62.
What is that? 6 and 62? Beautiful, there we go. So this will be
And
W
negative
plus
62.
62, W minus
It would
6.
be negative 62.
No, it would be positive because it's the positive 56.
Negative 62.
No,
I want negative.
bless you. You can want what you want. I don't want to pay my taxes. I still got to pay them. Now,
That was your excuse.
it's the most apropos one. Now, maybe it's the guy on the left.
Yeah, maybe it is.
Maybe it's the guy on the right. If I solve this one, I don't think so. I don't get a negative width. Know what I mean?
So
And then this one,
6.
W is 6.
Oh, you divide by 4.
What?
4 and the 4.
Oh, dang it!
Oh, hold it. Yo muy malo.
Y'all.
So I gotta divide back in by 4. Sorry about that, guys.
Yeah.
So, this reduces to 31 over 2, which would then become 2W plus 31 equals 0. And then this reduces to 3 over 2, which would become 2W minus 3 equals 0. Now, can we all agree that the guy on the left is going to work out to be negative?
Totes my go.
Yes, so done. Goat literally toasted.
Wait.
Now, next. Hold it. Add 3. Add 3. 2W is 3. Divide by 2. W is 1.5.
Or
Question.
3 over 10.
Hold it. Hey, I can't hear. What was that? Because this becomes 3 over 2, and I got to do the elementary school thing. Oh, because 62 over 4 reduces to 31 over 2, so there's still a 2 there to put there. Okay, hey, excuse me. Let's go back and just make sure everything makes sense. 1.5 all the way around, and I'm going to get 15 times 19, which is going to get me there. Okay, hasta la vista, vaya con Dios, toodaloo. Ta-ta, arrivederci, smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Yes.